5-minute presentations, 2-minute Q&A. If you have questions for the presenters, please go ahead and line up at the mic during their presentation because it's got to be rapid. And actually, if you have a presentation that you want to give during this lightning round session, email projects@hope.net with what you want to talk about, and we're going to try and add 2 or 3 at the end. So if you have a presentation you want to give in 5 minutes, email projects@hope.net, and with some information about who you are so we can call you. It's up to you.
Yeah, hi, I'm NG. I'm presenting you Schleuder. And to start, I'm going to ask who of you are sending GPG encrypted emails? Yeah, a few. And who of you are sending it to multiple persons? Some. And you got some problems with the membership management of these and all the keys and so on. So it can kind of get crappy to write GPG encrypted emails to multiple persons, like some kind of mailing list. So that's why we started Schleuder. And wait. Okay. Yeah, so Schleuder is just a German word for slingshot. And it's a GPG-enabled mailing list software, so it has a private key, and you write an email to that list with that private key encrypted, and it sends the emails it distributes then to all the members encrypted with their keys. It's written in Ruby, licensed under GPL version 2, and it probably got some chunky bacon in it. Maybe you find it. So it's completely MTA agnostic. We know that it works with postfix, QMail, and Exim. It stripes off headers of the senders, so you have kind of pseudonymity amongst subscribers. You don't see it from where they have actually sent the mail. It's extendable through plugins. You can write your own plugins to do some stuff when you send an email to it. So for example, we also say that it's with remailer capability. So you can send an email to the list and containing a special keyword and saying, send that email also out to someone else, not on the list, which then makes the list usable as a shared contact address with a GPG key. It works so far reliable. We have some lists with a couple of 100 users. The resend feature was recently tested with over 300 outgoing mails, so it should work good. The administration works over email, and you're sending encrypted and signed email to the list with special commands, which then administrates the list. And Schleuder verifies or authenticates you by the email signature. And it's also, but totally optionally, you can administrate by a little web interface, which is separate from the list, and that's totally optional to use. So beware. You have to trust the server. There are certain drawbacks in the design we did because there is a private key for the list. It has to be somewhere on the server, and it has to decrypt the emails, so you have to trust that server. We're not sure how it really scales with very large lists. We like to hear from people how big their lists are and how it works. There are probably some features missing. We got a bug tracker and a feature tracker. There are some in. We are still working on some features. But if you see other things, just file a feature request. There are probably also some bugs left. You never know. We also like people to look at our code, to look at Schleuder and tell us what they think about it. Yeah, so you find the wiki at schleuder2.nadir.org. there is a contact address to meet, to contact developers, which is also a Schleuder list itself. So for example, if you send an email to schleuder2-sendkey@nadir.org, it will reply you with the public key of the list, and then you can start communicating in an encrypted fashion with us. So, and that's the fingerprint, and yeah, we'd like to hear your stories and feedback. That's it.
Questions? Okay, next presenter.
I'm around for the next day, so if you have questions, just contact me. Thanks.
This is David Huerta, and he's talking about the Haystack Project.
So if you've been to Tour Camp last year, CFP this year, or the HeatSync Labs meeting from July 1st, if you guys know what HeatSync Labs is, you do now. They're a hackerspace. They're in Arizona. We exist. Anyway, you've already seen this, except this is going to be a lot shorter. So just a heads up on that. OK, so basically the idea behind this is web search history obfuscation. It's an idea that's been talked about for a long time. The idea of, instead of trying to like hide what your searches are, put them out there with a bunch of other crap to make it hard for a person to discern which were created by a human being and which were created by a machine. So, and one of the issues behind this is that the thing that sort of spurred it is in 2005, the DOJ tried to have certain information related to web search history coughed over from Google. They fought back, but the thing is, they might not always, so it's just something to keep in mind that we have a company that is sitting on what is quickly becoming the largest store of personal information in the history of mankind. It's something that we might want to keep in mind. Okay, so in this case, we do a lot of searches within your searches. You do a Google search through Haystack Project search, and it'll add a bunch of other searches to the mix so that when you look at your search history, it looks like you went to a bunch of places that you didn't. The algorithm is fairly simple right now. I mean, basically, it takes a random mix between 0 to 20 of other terms that it would mix in with your search term, and then randomize the order that it's sent to Google. The source is very limited right now. It's actually Google Hot Trends, which is not ideal because it's the same company that owns the search engine. Differential search law. Anyway, so that's the first part of it. The other part of it is the part where using a Grease Monkey user script comes in. If you're familiar with the Grease Monkey add-in for Firefox, or the heavily crippled user script support in Opera and Chrome, then you know what I'm talking about. In this case, there is a very special function that lets you grab content from another domain and add it to somewhere else. In this case, it's running within the browser, so it's not technically, there's no domains in that context, which is why it's theoretically able to do this, maybe. So in this case, this is going and grabbing your Google search results page for the fake terms, and then reorganizing the redirect URL that Google builds to keep track of what you clicked on. So in addition to a bunch of stuff that you fake searched, you also have a lot of stuff that you fake clicked added into the mix within a randomized number with a bias of 1 to 5, but also with the possibility of getting 0 to whatever total results you got on your search page would be. So that's that next step. In this case, this is all client-side code. So you'll notice haystackproject.org has a lot of .html. Actually, it has only .htm pages. There's no .php, there's no rhtml, it's not a Rails app. Basically, when it comes to server-side code, there are a lot of companies and new search services out there that have the promise of saying, well, we're the most private search engine out there, you should use us instead, as well as proxies. But the thing is that with that, you entail a certain amount of trust so that it's only doing exactly what it's promising to. Something that I learned recently was that the European Union has something called the Privy Seal, which has somebody go in and audit and make sure that it's doing what it's doing and that sort of thing, but that still entails a certain amount of trust, and in this case is totally unnecessary because this is all client-side JavaScript running within a Grease Monkey context so it can do crazy XSS stuff. So, and that's the other thing, it's incomplete. So we want developers. And by we, I mean me. So this is why. So I'm not the only person working on this. We have open source code available on GitHub. Of course, it would have to be open source. I mean, the whole point is you don't have to trust anything. So it's FRS GPL licensed, which is actually really easy to implement because it's client-side code, so it's already there. And you should fork us on GitHub when you get the chance. Do we have any questions? I have 1 minute, 35 seconds left. Haystackproject.org is the actual search page. So if you want to try this out, go ahead. If you guys want to play around with the code, it's on GitHub. Any questions? Oh, here we go.
When you were talking about how the search engine obfuscation worked earlier, you made it sound like on your end it also looks like your results are going to be obfuscated. Mm-hmm. Is there any way to prevent this? Because that would drastically decrease usability. And
oh, yeah. Oh, what I meant was, and there's a lot of terms that are used sort of ambiguously between a lot of different things. In this case, what I mean by adding terms to your search term, I mean, I guess I could say search phrases to your search phrases. So you have like one search for, puppies, and then you have like a bunch of other searches. The other searches run behind the scenes, and only yours opens up in its own pop-up window. So it's just like using Google regularly.
Right, I understood that. But I mean, if you wanted to, let's say you found something, had to close your window, and wanted to go back and look at what you searched for, mm-hmm. You're now going to see what you searched for, and then a whole bunch of other stuff you didn't search for. Is there any way to make it so you can see only what you searched for? That way you can look at what you've searched for in the past. I'm talking about your history, not what's displaying in the search.
Oh, if you want to like go back and look at your search history?
Yeah.
Yeah, I mean, it's going to be a mess, basically. So you can kind of go back and if you remember what you searched for, find it. If not, then it's going to be a big mess, so it's going to be hard to do that. Haystackproject.org or haystackproject.com, or actually, if you want to go directly to the actual web search application on the page itself, you have to install GreaseMonkey on Firefox to get it to run. You can just go haste.ac, so it's HAYST.ac, just kind of short and sweet. Any other questions?
Thank you.
Cool.
Next up is Michael Ravnitzky, and he's going to talk about interesting application for postal trucks.
Hi, put yourself back about 500 years. You're living in a village in Europe, no television, no newspapers, nothing. How do you get information? Well, there were these guys that went from town to town every week or two. The clock cycle was every 2 weeks or so, and they brought mail. But no one could write. A lot of people couldn't write back then. And if you were going to send a letter, the recipient paid, and it was some astronomical amount of money, equivalent to $10, $20 now, probably to send a letter, maybe even more, maybe $100. So very few people actually sent letters, but they carried these letters around, and what happened when the guy came into the town, he had his horn. The horn was a symbol of the Postal Service, and he brought a lot of news from what was going on all around. People pumped him they brought him to dinner. They said, "What's going on out there?" And they told him, and he collected intelligence and brought it. It was a sideband communication system. So this takes it and turns it on its head and says, here you have the Postal Fleet. They go almost everywhere, almost every day. They go almost everywhere, all around the country, all around the world, almost every day. Why can't we just pick up information using the Postal Fleet? Mobile sensors can sweep through an area and pick up data like equivalent to a much, much larger number of fixed sensors. You can have overlapping fine-grained coverage because they're going so many different places. You can link useful measurements to precise locations, like some of the speakers have described earlier this morning, or the vendors are talking about using GPS tools. Postal fleets follow the patterns of human activity. They go where the people are, they go where the businesses are. You can extract value from the aspects of postal delivery routes. Everybody knows, because you can get it on the internet for free, the postal carrier routes, the zip code data. You know where the trucks are going. You can look that stuff up. There's places to find it. And businesses use that for demographic purposes to send out ads. So you can select places where you want to get data from. If you wanted to get data, for example, near certain types of factories that produce certain kind of chemicals and you're afraid that those chemicals are going to get out into the environment, you can pick the postal routes that are near those places and collect that data. So there's a whole bunch of applications. I'll run through some of them that you could use. You could use it for chemical, biological, and radiological sensing. Let's say you wanted to have the Olympics in Atlanta. You put some postal trucks out there, you could sense for those things. You can monitor industrial facilities in various places. You can detect chemical emissions. You can monitor air quality, create air quality maps. You can find a baseline so you can find out if anything's straying from that baseline, and thus you can determine if there's a problem in a plant. You can measure all sorts of interesting stuff. Remember, you're measuring the time, the place, you're creating a map, you are creating a topographic structure in more than 3 dimensions. You can find out where there's poor broadcasting reception. You can find out where there's weak wireless or cell phone coverage. You can map it, identify it, figure out which cell towers are failing or going to fail soon. You can improve the quality of the signal. You can collect arrays of fine-grained weather data to help predict weather better. What I mean by that is you can collect humidity and temperature and so on all at the same time, so you can do mathematical analysis to correlate them and figure out what's really going on with weather. You can sense road conditions and pothole mapping. You could either use accelerometers, you could use laser sensing, ultrasonics, whatever, but you can figure out which roads are the worst, which ones need to be fixed now, and just because I think my road is worse doesn't mean that there's other roads that shouldn't be fixed first. So it's a qualitative method of mapping out road quality and potholes and finding them. You could say, well, the postal trucks will steer around them, but they're not going to steer around them every single day. Over 6 or 7 days, you'll collect a lot of average data that works. You could detect natural gas leaks. And it turns out, from doing some research, it turns out that there's tons of natural gas leaks that are going on because the systems and the pipelines are very old. There's gas pipelines that are made of wood. They leak like a sieve in a lot of places. And sometimes you can smell it, sometimes you can't. But there's a ton of... Now, if it collects in one place, it can explode. So this is a public safety opportunity. You could scan for... Now, this is a privacy issue, of course. But you could scan for license plates for stolen vehicles. And I'm not advocating this. I'm just saying it's potential, possible. You could... Because methamphetamine drug labs produce certain types of specific chemicals, you could easily identify those. You could identify locations where explosives have been or are, or other types of dangerous materials by using very selective sensors for particular chemicals. Now, you could collect street view imagery, not just once like Google does, but every day if you wanted to, but obviously there's huge privacy implications. You could record acoustic profiles to map ambient sound levels in cities near factories. You could figure out, are these factories really too noisy, like people have been complaining about? You can use the spectrum analysis of the sound to figure out if there's things creating noise that are problems. You can also use you can collect ultrasonic and infrasound data too, not just audible.
30 seconds.
Okay, I'll skip some of these, but biological surveys, you could disperse insect pheromones to provide pest control. You could sense radioactive materials. You could map electric fields and magnetic fields to help with exposure in humans, which is thought to be dangerous. You could collect utility data. So once you build a baseline map, you can find out what's changing on a very rapid basis, and it can be a small change. You can also put things on post offices because they are 24/7. They're available. So there's business models that I won't talk about, but the Postal Service can either just lease out everything or they can do some of the stuff themselves. They probably aren't very good at this stuff, so they shouldn't get involved in that, really. And there's obviously some societal and privacy implications, which I don't touch on here, but I've written a whole paper about it, but I think that it's very, very important. Google had a problem, some public relations problems recently with collecting Street View data, but they were also collecting Wi-Fi signals for very good reasons, obviously, but they were having problems. So there's some issues that one would have to take into account. But basically, in short, just to conclude, any sensing that postal vehicles do, Postal Service is very trusted. It should be consistent with the trusted role of the Postal Service in our society. Thank you.
Questions? Are there any questions?
So, correct me if I'm wrong about this, but I assume that the postal truck itself, each truck doesn't go very far. Like, each town has, a couple trucks that would go through the town. So if you're putting all this expensive equipment into a truck, but it's only staying within the town, how would you get this widespread, gathering of information?
That's a good question. First of all, the average route for a postal truck is about 12 or 14 miles. You're right, they're pretty short routes. And on the rural, that's the city routes or the urban routes. The rural routes are about 40 miles, and they can go up to 70 miles even. But the routes are short. There's a lot of postal trucks. They deploy during the day. They go out. But think about this. It's a moving cloud of particles. And even though they're not all in the same place, they're all over the place and during that entire period of time. And these are not expensive. I don't think that you'd need a lot of expensive gear. Some of the gear that some of the vendors have been showing off is a good part of that. You could have a BlackBerry with a sensor attached to it, and you'd probably have most of what you need. So I think that the cost of outfitting a vehicle could be something as simple as a piece of Velcro on the side with a BlackBerry attached to a couple other boards. So that's what I'm thinking, that it wouldn't be very expensive. But you could also do it with only a few of these things and then just move them around. Every week you move it to a different location.
Any more questions? Okay.
Thank you.
Next up is Josh Davidson, and he's going to talk about the idea of the desktop on computers.
Yeah, desktop, it's a really good idea. I think instead of using command line interfaces, we should have this, no, actually, here's what I'm going to talk about, is desktop metaphor, which is the current graphical protocol, basically, for interacting with computers, the current standard paradigm. I believe that it is a detriment to the advancement of technology, continuing to use a desktop metaphor. So I'll explain why it's bad, and I'll tell you why we could make something that's better. So first of all, some background on the desktop metaphor. It was created originally 40 years ago, 1970. That was a really long time ago. The Beatles broke up that year. Nixon was president at the time. Xerox created it, as a lot of you probably know. Apple popularized it. Microsoft monopolized it. And it was meant to be a metaphorical electronic desktop to ease a transition for businessmen from their rigid, mahogany desks over to an equally rigid computer interface, an electronic desk. So basically, a desktop is a 2D, it's flat. The desktop is the root of everything that exists on the computer. Everything goes on top of that. So it's just like a real desk. Now, it keeps computing locked in an arcane, static, business-oriented state. Today's fast-paced, on-the-go, in-the-pocket, socialized, information-based computing no longer fits with this paradigm. And so continued use of this desktop interface is basically keeping us back in this business-focused realm, where it doesn't really seem like on the surface like it's that big of a deal, like, well, I can browse the web, I can do everything that I want to do through this desktop interface. It doesn't matter if it's based on this old, 1970s idea that Xerox came up with. Well, it actually is restricting the potential capabilities that you could have with a different sort of human-computer interface. Whereas nowadays, how it could be better, computers are, as you guys probably know more than anybody, computers can be used to make art and beauty instead of just being like a business machine or an office machine. End users don't understand that. We understand that. But in order for other people to be able to understand that and be able to access the cloud and the hyper-creativity and the infinite knowledge and use computers as a megaphone to humanity instead of just using them as these office tools, there has to be a change in their interface because that's all they see. And so now's the time to create a more consistent, general, organic life top that takes advantage of the immense power of the internet and integrates it with the internet. So I have a few ideas. Do I have much time left?
Yeah, you have some time.
Okay, I'll just give you a quick example of an alternative to like a desktop-based computer interface. Something I was thinking about was like a cell-based interface. So everything is based on a cell. So all of your individual files and applications are just cells, and cells can interact with each other, and you can see their interactions on the screen. Now, instead of being just 2D and being able to move up, down, left, and right, you can also zoom in and out. So you'd be able to zoom out, and all of your applications and files would shrink down into a single cell, and you would now see your entire social network of individual cells, and you could see the social network interaction. So you can see your friends interacting with friends. You can see your friend post a comment on somebody else's status update. You can see waves of interactivity flowing out through this network. So it kind of graphically visualizes like a social network, and you can continue to zoom out further and further, or zoom in further and further, so kind of a fractal-like. So that's just one example. You guys probably can come up with a million better ideas, but my main point is that the desktop metaphor is dead, and we need to abandon it and stop developing for it. Thank you. Do you have any questions?
Yeah, I have a couple actually.
Yes.
When you're talking about it being a 2D environment, but the physical interfaces we have are 2D, you can't easily have a mouse go up at the same time as it's going left and right.
Basically, I'm not saying that we're actually going to have like, you know, some sort of holographic interface or actually have a literally 3D interface. I'm just saying rather than having a desk-based interface, whereas I place something on the desk and I can move it up and down and left and right, you also will have this third dimension where you can zoom out and in. But that's just my one idea. You can come up with an even better 2D interface that's better than the desktop metaphor, I believe.
My other question is, what you're talking about seems mainly to be just about how you store files and programs, and you're integrating it with some social networking. It doesn't seem like it would actually change how we compute. It wouldn't change the programs themselves.
Well, I only went over a very brief explanation of my idea, which basically there's a lot of like, I can't even, there's not enough time to even go into it, but it's just my idea. Like, I could talk to you more about that afterwards, actually, if you'd like to, but that's just my idea. My main point is just that the desktop metaphor, I feel, is hindering the development of computers and people's ability to interact with computers. So anything that takes more advantage of, you know, the power of the internet and integrates better with that is going to be better than continuing to use this arcane desktop interface.
I think I would like to talk to you about that later.
All right, definitely.
Any more questions? No? Okay, that's the end of the lightning rounds. We didn't get any live submissions. If you would like to do a lightning talk tomorrow after the keynote, email projects@hope.net with lightning in the subject line and your phone number somewhere in the body of the email so we can get in touch with you. And that's it. Thank you.